discussing morphological source code axioms. We are working on the double arity short circuit. The isomorphism at the heart of statistical mechanics, the C standard library, and morphological source code, and many other things. The Yoneda-Lemma being one of them. We are working on the Yoneda-Lemma. We're working on deriving that at the moment. So far, all we've driven is this static morphism type, because we've created a Markovian historyless ontology, dynamical ontology, a singleton calculi, if you will. The only thing that matters is y prime, x prime. Unitary transformation. This is the most basic type of transformation. This is the most basic type of category. This is the most basic type of morphism. This is the most basic type of well, in morphological source code, but that byte word, technically ket. Okay, we're not going to get into brackets right now. We're not there yet. Okay. So what we need to do in order to get all this other juicy stuff is we have to have fibers or boosts, if we were going to think in a Lorentzian metric. But we're not. We're thinking in a topological metric, or a Yoneda-Lemma. Okay, so the fiber product is the set of pairs of elements from each x and y satisfying a simple equation in Z. So can you understand how basically it's like a list comprehension? Okay, so this static y prime, x prime, presumably there's some Turing machine that exists that transforms x to x prime and y to y prime, and it may itself transform it back, or it has a corollary, or there exists one such that, so presumably there is a Turing machine that does this operation. We'll call that not map. We'll call that a map, or cat. Yeah, cat. No, like concatenate, but single computations. Well, okay, we'll just go with that. Single computation. Unitary. No history. Reversible. This is our only given in electrodynamics on contemporary hardware. We are quantized. We have zeros and ones. We have the singleton computation, the single computation using singleton. Okay, so we talked about x and y mapping and satisfying such that Z is the thing that relates the meta computation that doesn't exist unless it does make sense in Z. So what we just talked about there, what the hell did we just talk about? Well, we talked about the future. We talked about branching predictions, but that doesn't make sense here. Where did we get that from? It's the same trick. The things one can observe, being each related to two states, are expressed naturally as a matrix array of numbers. One should consider the whole set of numbers together. So we are considering the fiber products exactly as the infinitesimal. So classical mechanics is using fibers, only it's using an infinitesimal fiber. What we call acceleration is really its position and momentum and an infinitesimal. An infinitesimal is trash. It's not noetic. It's certainly not Machian. I don't understand how Einstein dealt with it. I guess you don't have to do much of it in Einstein summation tensor calc, so maybe he got around it. Okay. So if x and y both map into z, we can reason about the fiber product of x and y with respect to z. Therefore, we can think about f and g mapping x and y to z. Fg maps for us. That matches in what it's mapping. This A and B is two different categories. Not groups, not sets, two different categories. So this out here is category land. A is category, B is a category. Such that in a universe, U, such that the universal object who is equipped with the maps onto x and y, such that the two paths to z evaluate to the same map, that one ought to concentrate one's attention on things which are grossly connected with what one can observe. The things one can observe, being each related to two states, are expressed naturally as a matrix array of numbers. One should consider the whole set of numbers together. This is the same type of assumption as a Markov assumption. It's the same type of assumption as a Yoneda-Lemma. It's the same. It's an isomorphism. I'm not saying it is. I'm not saying they're isomorphic with each other. They are. What I'm saying is it is isomorphism. Isomorphism, the categorical and therefore set theoretical elemental category, therefore, you know what I'm saying? This gives us an Arity short circuit that is key to replicator dynamics, Quineic statistical dynamics, morphological source code, the standard model of particle physics, general relativity, Hamiltonian dynamics, Lagrangian mechanics, classical mechanics, statistical mechanics, obviously, everything. Is there anything else we need to cover real quick before I start into the Markov? yes, we need to talk about morphism. Morphism is the set of morphological source code. And a morphism, as compared to a category or a set, is in motion. It is an action, a reaction, a message, a response, an observation. It's what Heisenberg told us about. It's the things one can observe, being each related to two states, are expressed naturally as a matrix array of numbers. Okay? So, when he says matrix array of numbers, one should consider the whole set of numbers together. The whole set of numbers together being the matrix mechanics expression of this particular enumeration or morphology or quanta that we're discussing, which would be essentially it would be the right side of an equation, and you would be able to have a bijective map onto that situation, such that you could call it a functor, and in this instance we'll just call the functor y, which is also a simple set corresponding to a singleton into the category, which is mapped to this, which we're interested in. So, elements from a plane set correspond to functions from a singleton into the set where the singleton's unique element is mapped to the set we're interested in. This bridges the set and category theoretic formulations of the fiber product. Okay, this is what we need to talk about, the fiber product. So, the fiber product doesn't exist as a concept here. Because in this situation, it's classical dynamics, or it's classical mechanics. It's based off of the infinitesimal. The only thing that matters is x and x prime, y and y prime. This is a memoryless, simple morphism type. Categorical morphism type. And bridging set and categorical formulations of the fiber product. Okay, so I have not explained to you what a fiber is at all. I've explained to you what a fiber isn't. Okay? Okay, let me say this. Objects of other categories may have their own notions of elements. We may find another object which corresponds to picking desired elements by mapping into them. That is what we just described as a category. So, what a morphism is it's a category of writing morphisms. Okay. I hope I hit record. Okay, thank God. The fiber product is a set of pairs of elements from x and y satisfying a simple equation in Z. So, Y maps to Z with G, X maps to Z with F, and what we're getting out of the Yoneda is the ability to... It's sort of a complex analysis. If X and Y both map into Z, we can reason about the fiber product of X and Y over Z. X mapping to Z through an F, Y mapping to Z through a G. We can reason about a thing called the fiber product of X and Y over Z. So, with basically what this is like is it's saying, like, with respect to a Z, we can have a product of X and Y. And it uses F and G. So, F and G maps from Y to Z and from X to Z. F and G does that. And what F and G imply is something called A implies B, which is categorical. So let me say that again. If X and Y both map into Z, we can reason about the fiber product of X and Y over Z. So if X maps into Z and Y maps into Z, we can reason about the fiber product of both of these things with respect to the thing that we were going to compare to. This is kind of the same thing as an infinitesimal, but it's logical and categorical, which it's way better than an infinitesimal, because we have categories. Category B, in a universe U. In a universe U such that the universal object who is equipped with maps into X and Y. So, okay, the universe, so A and B exist in the universe, and the universe is such that the universal object is equipped with maps into X and Y. This is the universe that our category exists in. The F and G map X and Y into Z with respect into creating category A, category B. So what we just did is the same thing as matrix mechanics. Same thing as Dirac, same thing as Heisenberg. One ought to concentrate one's attention on things which are grossly connected with what one can observe. The things one can observe, being each related to two states, are expressed naturally as a matrix array of numbers. One should consider the whole set of numbers together. So using just that axiom, we have taken that axiom. We've got an if X and Y both map into Z. So in the universe where we have that axiom, you know what? Let's talk about universes real quick. Git. So Git is like a physics without any bodies. It's like a universe without any motion, without any energy. So yes, it is noetic. It is Machian. Git, indeed, is a noetic Machian application. This is why it's so powerful. I can't believe no one. So Git, everything is a state in Git, and what is unique about Git is not that it is sort of doing the morphism, okay, but there's no dynamics to this morphism. So you can see Git is doing the exact same Arity short circuit that I'm doing, that Markov is doing, that Heisenberg and Dirac is doing. The difference with Git is that it's creating a substrate. There are no laws, there are no morphisms, there are no generators and no thermodynamics. All there is the universe U. In the universe U, there is a universal object who is equipped with maps into X and Y. So what Git is giving us is a universe where we can, using X and Y, map categories A and B to Z using functions F and G. Dude, we're talking about the Yoneda-Lemma basically, so this is gonna be a little confusing sounding. Doing so universally means that any other object which projects onto X and Y in the same way must map uniquely into the fiber product compatibly with its own projections. So now we've got completeness in this realm that we've created using just Heisenberg. So Git is infinitesimal. Okay, Git is Newtonian. There is nothing there, except what you put there. Technically what I meant to say, but it's just idiotic now that it came out of my mouth and I hear it. But yeah, Git is infinitesimal in the same way Newtonian kinematics is in physics. It describes what happens, but it does not explain why the system evolves or converges. Git is a projection of something deeper, and if that deeper thing existed, that deeper thing is morphological source code. Classical position, array of all possible transitions. So this is how we go. Very, very graceful, very, we're getting there, family. X to Y, Y to Z, F to G, A to B, N to U, U. So we've got U with, so now, okay, so we built the tower. Now let's go back down the tower and we can inject. So, okay, we've got U. So in the universe U, we've got category A and B in our universe U, and those categories A's and B's have morphisms, F and G, which maps X to Z and Y to Z. So we have a Z in every A and B. So each A and B that exists, there is a Z that exists. And such that a Z exists because an A and B exists, there also is a function G that maps Y to Z, and a function F that maps X to Z. So what we're doing is creating differential equations from scratch, ladies and gentlemen. Universe categories, morphisms, X and Y, Z. That doing so universally means that any object which projects onto X and Y in the same way must map uniquely onto the fiber product compatibly onto its own projections. So what that means is we've got a phenomenon. So in category A and category B within universe U, Z with respect to whatever Z is a phenomenological situation that inherently has a bijective map with all other Z's in all other A's and B's. Doing so universally means that any other object which projects onto X and Y in the same way must map uniquely into the fiber product compatibly with its own projections. This all is very, very nebulous and confusing in the default mode, that being morphology, morphisms. it is much simpler when if all objects present are sets, then the fiber product is just the set of pairs of elements from each x and y satisfying a simple equation in Z. So should y, x, z, a, and b all be elements of sets, which they are because they're categories, and should they correspond to functions from a singleton into that set where the singleton's unique element is mapped to the set that we're interested in, then what that would do is be a Quineic bridge, a phenomenological Quineic bridge, bridging the set and the category theoretical formulations of the fiber product. So worlds are colliding.